Indefinite integration. We first need to consider an example of differentiation. Let's look at differentiation before we look at integration. So for example, to differentiate y equals to x squared plus 3, part A, and part B, y equals to x squared minus 1. When you differentiate x squared plus 3, you multiply by the power and subtract 1 from the power. So it becomes 2x. When you differentiate 3, you get 0. So when you differentiate x squared plus 3 dy over dx is equals to 2x because the 3 becomes 0. When you differentiate y equals to x squared minus 1, the 2 comes in front and you subtract 1 from the power. So it becomes 2x. When you differentiate minus 1, it becomes 0. So dy over dx is equals to 2x. And if you notice, the answers are equal. Equal, it comes from the Greek word equitas, which means the same. So when you differentiate x squared plus 3 and x squared minus 1, you get 2x and you get 2x. It's the same. But you have plus 3 there, you have minus 1 there. So what we can say is that the gradient functions, dy over dx, is what they call the gradient functions, are the same. Since the graph of y equals to x squared minus 1 is just a translation of y equals to x squared plus 3. So you got the graph of y equals to x squared minus 1 and the graph of y equals to x squared plus 3. It's just a translation. Translation means they moved it up. And so the gradient function is the same. So if you use your graphics calculator and you plot the graphs of y equals to x squared plus 3 and y equals to x squared minus 1, it passes, the minus 1 is there, it passes the blue graph, x squared minus 1, it passes there at minus 1, and that's 3 there, and the plus 3, y equals x squared plus 3, passes at that point 3 there. So it's just a translation where you can move this 1, 2, 3, 4 up. So the gradient at x equals to minus 1, so you pick a point there, minus 1. The gradient here and the gradient here is the same. If you draw a tangent line to work out the gradient, draw a tangent line at the bottom to work out the gradient at that point, minus 1, is the same. So what you can say is at each value of x, the gradients of the two graphs is the same. Dy over dx is equals to 2x. So we can say indefinite integration is the reverse of differentiation. If we are given the gradient function and want to find the equation of the curve, we reverse the process of differentiation, but the constant is unknown. So we have x squared minus 3, x squared plus 3, x squared minus 1. We do not know the constant, whether it's plus 3 or minus 1. So we call it a plus c. So when we had y equals to x squared plus 3, y equals to x squared, y equals to x squared minus 1, we do not know the constant, so that's why I'll call it c there. So c is called the constant of integration or arbitrary constant. Constant of integration is the one I use all the time. So the equation of y equals to x squared plus c forms a family of curves. For example 2, find the equation of the family of curves which have a gradient function given by dy over dx equals to 6x squared. So we're going to do the integral. So we have dy over dx equals to 6x squared. The reverse of rule for differentiation. Add 1 to the power, divide by the new power. So add 1 to 2, it becomes 3. and you divide by that 3. So this will add 1 to the power and divide by the new power. And for differentiation, it was subtract 1 from the power and multiply by the power. So integration is the reverse. So what we do now is, when you add 1 to 2, it becomes 3, and you divide by 3. So 6 divided by 3, 3 divided by 3 is 1, and 6 divided by 3 is 2. So you have 2x cubed plus c. So we add 1 to the power, and then divide by that new power. And then at the end, we add c, the constant of integration. And we could check the answer by differentiating. If you find dy over dx, you multiply by the power, it becomes 3 times 2 becomes 6x, subtract 1 from the power, 6x squared, which is the same like what you started with.